We'll proceed in vector algebra and calculus. Vector algebra and calculus. This is the topic that we are covering thoroughly because this is considered as the future of mathematics. The vector is considered as future of mathematics because whatever mathematics we have seen till now, that is algebra and calculus only. Maximum different coordinate system that comes into the picture. But if I need to add direction there, then vector comes. Vector has very simple grammar. Vector is represented through orthogonal components. So vector is represented through orthogonal components. Like, okay, so like if this is x-axis and this is y-axis, if I have any vector, then how vector can be represented? This vector is v. Consider this vector is v. If this vector is v, then v must be represented through orthogonal axis. There is nothing called v. Okay, I have a vector called, like in algebra, I say, consider there is a variable called v. Consider there is a vector called v. No. In vector, there is nothing called v. Vector must be addition of orthogonal component. Okay, if it is addition of orthogonal component, what about this vector? It is along the direction of one orthogonal component. X-axis, y-axis. They are called orthogonal component. Or if this is xy plane, then this is called z-axis. So if this is x-axis, y-axis in xy plane, if I have a vector that is along x-axis, if I have a vector that is along x-axis, then still it must be represented through all the orthogonal components. Then if this vector is passing through a point called 2 comma 0, 2 comma 0, then this vector is 2i plus 0j, 2i plus 0j. If this vector is crossing from a point 2 comma 1, then it is 2i plus j. If it is parallel to j axis, then it is 0i plus j. All the vector must be represented through orthogonal component. That is the vector. Vector without orthogonal component is not a real vector. Okay, so this is what we are seeing as far as vector is concerned. Okay, now if vector is combination of orthogonal components, if there is a vector called 2i plus j, then it is as good as there is a one energy that is coming from the minus x-axis going towards x-axis, and it is 2i. There is another vector that is coming from minus y-axis and it is going toward y-axis, and it is j. If these two vectors they collide at the origin and they form one new vector, then it is 2i vector plus j vector. Combination of two vector orthogonal vector, that is 2i plus j. Okay, so this can be also understood. Vector can also be understood in this fashion, where if it is 2i plus j, then one vector j and one vector 2i they got combined at origin and they made 2i plus j. So this is another way of demonstrating a vector. A vector can be algebraic vector. Algebraic vector means it is changing at every point. This vector is constant. 2i plus j vector is constant. Constant vector in the sense that this vector is, you take any point here, this vector 2i plus ij. Generally, vector are considered a direction and magnitude. So not in the offset or something like that. So if this is 2i plus j vector is there, all these parallel vectors are 2i plus j only, 2i plus j. But there can be a chance that at each point vector would be different. If that is the case, then point is represented through the algebra x comma y. Then the orthogonal components of the vector is function over x and y. Okay, so if I say my vector is y plus sine xi. Up, 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 up. My vector is y plus sine x, bracket close, I. Or y cos x I. Y cos x I plus y plus sine x j. I believe it's all right. Okay, what is the vector? Vector is y cos x, y into cos x. Vector is y into cos x I plus in braces y plus sin x j. Now its x component is y cos x. X component is not a constant, it's not a numeric. X component is y plus y into cos x. X component of the vector is a variable, it is a function over x and y. What about jth component, that is y component? Jth component is y plus cos x. Jth component is y plus sin x. S component is y into cos x. So x component and y component both are algebra and both are a function over x and y. This is called algebraic vector. Now this vector would be changeable at every moment because it is function over x and y. The way x and y point is changing, it will recalculate y cos x and y plus sin x, and that way it will keep changing. This is algebraic vector, whatever it is. Now we are in discussion for the path independence in energy calculation from a force vector field. If there is a force vector field, like we took example of the earth, like if this is the earth, then earth attracts everything towards its center. Now consider the earth gravitational pull, that is the force is xi plus yj, but actually it is minus gm r vector divided by r to the power 3. This is the actual earth gravitational force, but it is, I believe, for demonstration purpose, simple I can take the earth gravitational pull is xi plus yj. If that is the case, then gravitational pull at origin is 0. But as we go, gravitational pull will increase and towards this direction. So toward this direction, I can make it minus. Minus means opposite direction. So gravitational force of the earth is minus xi plus yj. But as per the xi plus yj, if someone is going far from the center, the gravitational pull is increasing. But consider like this one. Consider it is xi plus yj, not minus 1. This is the earth or any force. Consider there is a something that is kept at the origin, and then whatever you see everywhere, there is a force from the origin. There is a force from the origin. That is the quality of the energy, that is energy source that is kept out at the origin. If you keep any item here, it will try to push it. Will try to push it. Okay, xi plus yj, xi, or okay, I'll rephrase it, minus xi plus yj, minus and in braces xi plus yj. Now it is better. Minus in braces xi plus yj, means everything it will pull towards its center. Everything it will pull towards its center. But if it is far from this, then minus xi plus yj, the force will be more. Earth is force will be less if it is far, because it is 1 by r to the power 3, whatever it is. It is minus xi plus yj. Then what is the work done? What is the work done in bringing any item from here to here, from point A to point B? Then work done is nothing but the work done by this force is nothing but that force vector dot d of position vector. This is what we have learned till now. If it is algebra, and it is algebra, if it is algebra, then multiplication of independent component and dependent component is not straightforward. X into x is not x square as per the calculus. If one x is independent and one x is dependent, then x into x is x to the power 2 by 2. X square into x is not x to the power 3. x square into x is x to the power 3 by 3. This is integral calculus because it calculates the multiplication through calculation of the area of the graph. And that area of the graph where one is x-axis and one is x square, then it will be this curve. Then that area is x to the power 3 by 3. So that is a scenario. So net energy, if any item, if this is a gravitational pull of any planet, an equation is minus xi plus yj minus and in braces xi plus yj or minus xi minus yj, then it is attracting item towards itself. Okay, means it means that it is attracting item towards itself. Okay, so it means that it is attracting item towards itself. So if that is the case, then what is the energy this planet is imparting on the body when it is coming? Consider that this is a planet. This is a planet. Hope. I mean, this is really a planet. This is really a planet, and there is one asteroid or one meteorite, okay, or one comet. This is a planet, and whose attraction is minus xi minus yj. Means if x and y is growing, its attraction is growing. It should be other way, 1 by minus xi minus yj. But for simplicity, I am keeping like this. Now there is a comet that is passing through the planet. Okay, now planet is happy, but as comet is coming under the gravitational pull of the planet, the comet is coming toward the planet. Okay, if something is moving, then there is energy involved in it. Who is spending the energy? This planet is spending the energy. Energy is going out from this planet, and then that item is moving like this. If it moves from A to point B, how much energy this planet released? That is under question mark. If someone is attracting some item, then it is losing energy. It is not that free. If earth is attracting anything, earth is losing money. That is another thing where from earth is keep on getting the energy. That is the big thing. Earth keep on getting the energy where from, but it is keep on losing the energy. So whatever, the planet is losing energy, and comet that came in the gravitational pull of the planet, now that planet is coming from A to B. How much energy it lost? Okay, now path independence means if it is coming from point A to B, this is B point, this is A point. How much energy it lost? Or if comet is coming in a circular direction from point A to B, or it is coming like a staircase from point A to B, it is coming like a zigzag manner from point, but point A is there, point B is there. How much energy it would lose? If it is force, if the gravitational force is path independent, then the energy that this planet is imparting on this comet is same. If it is path independent, if the gravitational pull is path independent, then this comet come from point A to B like a straight, or it come in a circular fashion, or it come in a staircase fashion, it come in a zigzag fashion, it comes like in a parabolic fashion. If it is coming from point A to B, points are matter, point matter, begin point and end point matter, not the way comet is coming. The energy that this planet is imparting this planet comet to come from one point to another point, that is constant. If the force, if the gravitational force is constant, is path independent. This is the biggest invention, I personally believe, or one of the biggest inventions that happened in mathematics, where algebra and calculus they entered vector arena. If they enter vector arena, then it finds any vector field is path independent. It is very big thing. If you know it is path independent, then what you know that energy what you are going to receive depends upon point A and point B only rather than the path you take. Then why you take different kind of path, not required. Okay, not required. Just go straight. That's it. But if you go by different path and you receive more energy from the energy source, then certainly from point A to point B, you will take a path where you will fetch maximum energy from the energy source. But if it is path independent, then you go straight forward because you get same energy in less time only. So that is the story of path independence. Now, path independence, what we have seen till now. So, path independence is there, the point A and point B matters. Only point A and point B matter. What we saw next, how we calculate the energy calculation, that is force vector dot D is integration, D of position vector. Energy is actually force vector dot product with the displacement vector. That is the energy. But when it comes to calculus algebra, it is force vector dot D of position vector, not displacement vector, D of position vector. Whatever we calculate. So position vector for any path, if this comet is coming from point A to B in any path, if I take any point on the path and from origin, if I draw a line, then that line, if that point is x comma y, then that line, the position vector will be xi plus yj. That is constant. You take any path, position vector will be xi plus yj. What is the difference between different paths is y and x relationship will be different. If it is a straight line, then there is a linear relationship. Okay, this is what we have seen. Okay, so if the planet is kept at the center and one comet is moving like this, then path, if I take any point here that is x comma y, then the position vector is xi plus yj. But y and x relationship is y equal to square root of a square minus x square as per the circle. If it is traveling in a straight line, then it can be y plus x equal to 3, then y equal to 3 minus x. That relationship is different. But in abstract notation, position vector is always xi plus yj. Force vector field is capital F that can be dissociated into F1i vector plus F2j vector. Now F1i plus F2j dot product of d of xi plus xj. It becomes F1 dx plus F2 dy. What if this integration compute it to an algebraic function, that is small g? Small g is an algebraic function of x and y. F1 dx plus F2 dy, if it computes to small g x comma y, then anyway, we know that integration of F1 dx plus F2 dy, F1 dx plus F2 dy is g, that is algebraic function of small g, where F1 and F2 are capital. Then if I differentiate g with x, dg by dx, and I differentiate g by y, dg by dy, and then if f1 is dg by dx somehow, f2 is dg by dy, then it is considered as path independent. This is what we have seen till now. If capital F1 dx plus F2 dy is the net energy that is going away from the energy source, and that integration leads it to gxy, g, small g, and if dg by dx is F1, dg by dy is F2, then this is path independent. Okay, this proves that this integration, if it leads to another function gx, not necessarily that for every f, dg by dx will be f1 and dg by dy will be f2. If it is happening like this, then we can keep it there. f1 is dg by dx, dg by dx into dx plus dg by dy into dy. It will come as 2dg or dg. dg integration is g1. So it fits out there. Okay, but whatever. We saw that if that is the case, that f1 equal to dg by dx and f2 equal to dg by dy, this proves that g equal to f1 dx and g equal to f2 dy, whatever. This proves that it is not dependent upon the path, it is dependent only on the force field if relationship is there. If we are calculating the energy calculation f1 dx plus f2 dy is g, and dg by dx is f1 and dg by, it will not happen with every case. This is what we have seen in the past video. The question is arising that if this is the case, that dg by dx is f1 and dg by dy is f2, then it is considered as path independent. Path independent. Force field is path independent. Under any force field capital F, if you move an item from here to here, that is point B and point A, either in a circular fashion or in a straight line, the energy imparted by this force is independent of the path and it depends only on point A and B. This is what we are seeing. So F1 dx plus F2 dy, if F is F, that is F equal to F1 I plus F2 j, if capital F force field is path independent, then whatever g we are getting, that is dependent only upon f1 and f2, not upon the path, that is dxi xi plus yj. Because dg by dx is f1, dg by dy is f2. Means g is only dependent upon f1 and f2, not on the path. Then limit is a to b. Then it is dependent upon limit. So if the net energy calculation is dependent only upon the force vector and limit a to b, then it is called path independent. One proof we have given, we took 2 point A and one point is a comma b, another point is x0 y0. One path to go there is first go vertically and they go horizontally, and another path is first go horizontally and go vertically, and then calculate. So please watch previous video. This is not our proof, it is available on the every place. What is our proof for proving that path independence? Means if dgx by dx and dg by dy, if it is f1 f2, then it is path independent. Now consider that I have a sphere. This is not planet now. Consider that I have a sphere. If I have a sphere, then this is centered at the origin. This is centered up. Let's say, see in the two dimensional first. If I have a circle and this is in xy plane, this is x axis, this is y axis. Okay, this is kind of, this is x axis and this is y axis. This is x axis and this is y axis. Now, at any moment, what is the equation of a line that is tangent at that point? Consider there is a point called x0, y0. Point called x0, y0. What is the equation of the line that is tangent at this point? Anyone would say immediately calculate dy by dx and get the value at x equal to x0. Whatever comes, y equal to dy by dx at x equal to x0 into x plus any constant. That is the equation of this line. This proves that if this point is x comma y is keep on changing, the equation of tangential line is same, is different at different point, because dy by dx at different point is same, is different. Okay, but dy by dx can be an algebraic equation itself. Like, consider this is a sinusoidal. This is a sinusoidal curve. Consider this is a sinusoidal curve. If this is a sinusoidal curve, then what is the equation of the line that is tangent at each point? Okay, then someone would say calculate dy by dx and get the dy by dx value at that point, then y equal to mx plus c. Y equal to dy by dx at that point into x plus c. That is the equation of the line at that point. So keep on changing dy by dx based upon the point. That is the line. Now, if the line, the curve is sin x, the dy by dx is cos x. Y equal to cos x into x. Y equal to cos x into x plus any constant. Leave the constant right now. Y equal to cos x into x. That is the equation of the tangential line. First, I want tangential line equation at any point. Tell me what the point. Just keep changing cos x and you keep getting different line. So the tangential line at any point, the equation of tangential line at any point can be algebraic also. Y equal to cos x into x. That, what is this? This is equation of your line. Y equal to cos x into x. Keep changing x cos x. Okay, keep changing. Or someone can say y equal to cos alpha into x. Keep changing alpha as different x value. Keep getting different line. If alpha is 45 degree, then it is y equal to 1 by a square root of 2 into x. That is the line. If it is 60 degree, if it is 30 degree, if it is 0 degree, if it is 0 degree, then what is the equation of the tangential line? Y equal to cos 0. Cos 0 means 1. Cos 0 means 1. I believe so. Cos 0 means 1. If cos 0 means 1, then y equal to x. That is the line. Okay, this proves that when sinusoidal wave, this is the sinusoidal. So when sinusoidal starts from here, at that moment, if I draw the a tangential line that is at 45 degree, knowingly, unknowingly. What about tangent at the peak that is 90 degree? Okay, at the peak that is pi by 2. Cos pi by 2 is 0, means 0. Y equal to 0x. Y equal to 0. Y equal to 0 means it is parallel to the x-axis. Certainly, if this is the sin x, then then it is parallel to the x-axis. Certainly. Okay. Then, like this, I get the equation of a line that is again algebraic. Okay. Very nice. What about delta y? Y equal to mx. What about delta I? If I if I make delta exchange, y equal to mx, m into delta x. Now, at any point I make a delta exchange, then how much delta y would change? What it is? So I'm saying y equal to cos x into x, where cos x will carry a value where I'll change the x value. Now at any point x, calculate the cos x, and at that point if I make slight change in x, delta x, makes sense? This is our proof for the path independence. This is not available in any of the book. Okay, this is x-axis, this is sinusoidal curve. If this is sinusoidal curve, then if I talk about tangential line here, that point is x0. That point is x0. On the x-axis, that point is x0, and this point is x0 comma function over x0 or sine x0. At this point, what is the equation of the tangential line? That is y equal to dy by dx at x equal to x0 into x, y equal to cos x0 into x. That is the equation of the tangential line. If that is the case at x0 point, if I move x, delta x, so at this point, x0 point, this is the height, this is the y height that is seen, y equal to cos x equal to x0, cos x0 into x. If you calculate, means cos x0 into x0. Okay, so that is the y at that point. Now, what if you move delta x from there? That is cos x plus delta x0 plus delta x, cos bracket x0 plus delta x plus delta x. This is the new y. Or I can say, what is the delta y if I bring delta everywhere? Delta, if y equal to dy by dx into x. Now, at any point x0, what is delta y? Delta y equal to dy by dx into delta x. Means if I move at x equal to x0, at x equal to x0, what is the y? Now move delta x from there and see what is the y. What is change in the y I see when there is a delta x change at point x equal to x0? Or in algebraic form, I can say delta y equal to dy by dx delta x. Okay. Then now you have to find dy by dx at every x equal to x0. If you are trying to find x as pi by 2, then at pi by 2 point, if you make delta x change, okay, then how much delta y would change? That is dy by. So here at per calculation, nothing. At pi by 4, then it is 1 by a square root of 2 delta x. Delta y is 1 by a square root of 2 delta x. If y equal to dy by dx into x, then change in y when there is a change in x at delta x is y equal to dy by dx delta x. Okay, I believe it makes sense. Okay, now let's consider 3D shape. Now I have a 3D. I have a 3D. Now if I have a 3D, then there are two planes here. This is x-axis, this is y-axis. This is x-axis, this is y-axis, this is z-axis. Then this is xz plane, this is yz plane, this is xz plane, this is yz plane. If that is the case, then if I cut it into xz plane, then it will make a circle. Up, up, up. We are covering path independence in very big detail because this is the biggest thing generally I believe that people found out through the vector. It was not possible without vector. Now if I cut that sphere in xz plane, it will resolve in a circle. If it resolve in a circle, then height is z and this is x. At any point, if I talk about a tangential line equation, then it will be z equal to dz by dx into x. Makes sense? Now, if I cut it yz plane and there is a circle again, and if I talk about any tangential line over the yz plane in the cut, then it will be z equal to dz by dy into y. Okay, I believe it's all right. What it proves, the equation of tangential line means, okay, so I will move forward. It is not that easy, but this is more kind of a proof that can be under, can be take you anyone to the bigger height. Okay, so now the question arises is that consider that I have one is z equal to dz by dx into x and one is z equal to dz by dy into y. Okay, it means that if I take consider that the plane we are talking about, the plane, the 3D we are talking about is a sphere. Consider 3D I am talking about is a plane. This is also a 3D. This is xy plane. This is x-axis and this is y-axis. This is x-axis and this is y-axis. Okay. That 3D I'm talking about, it is a plane. Consider it is a plane. If it is a plane, then if I do like this, then there is dy, then there is a dz by dx. Okay, dz by dx is constant at each point along the x-axis because the slope is constant everywhere. Okay, if I'm trying to find a slope at any point x equal to x0, what is the height? At any point, what is the, if it is, this plane is kept at the xy plane. At any point x equal to x0, what is the height? 0. At any point y equal to y0, what is the height? 0. If I move like this, then at any point x equal to x0, what is the height? The height is dz by dx into x, where x is at x equal to x0. That is the height. If I move only in y direction, then at any point y, what is the height? That is dz by dy into y. Keep y equal to y0. If I do both, if I do both, then at any point x0, y0, what is the height? First, whatever height you get here, then add it another one. That is that, because you see, consider this point. This point, if you see, it came at this level. And then if I keep the x-axis constant, first y-axis constant, then it came like this. If I keep x-axis, it went even up. So addition of both. So at any point, if it is a flat surface, then at any point x0, y0, what is the z? What is the height? Z equal to dz by dx into x plus dz by dy into y. Make sense? Now, if that is the case, then let's come back to this sphere. Now, a sphere, if I take any point x comma y, then there are two tangents at this point. One in xz plane. That tangent is like this. One is in yz plane. The tangent is like this. One is like this because if I cut like this, there will be a circle. And at this point, there will be a tangent like this. If I cut like this, then there is again a circle. Then at that point, if I take a circle, there will be tangent like this. One tangent is like this, one tangent is like this. Okay. Now, if I make a surface with these two tangents, okay, that will be a flat surface. If I make if I take these two surfaces, if I take this one line and if I take another line, one is in xz plane and another is in yz plane, it will make a surface. Okay, that is called tangential surface. Tangential surface is nothing but in xz plane, what is the tangent line, and in yz plane, what is the tangent line. If you make a surface, that is called tangential surface. Show me what is your tangential surface. So at any point, this is tangential surface. Hope, 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 hope. This is 3D. What is the equation of the tangential surface at any point x0, y0? Then it is dz by the equation of tangential surface. Surface is a flat surface. The equation is z equal to dz by dx into x plus dz by dy into y. At dz by dx is calculated at x equal to x0 and dz by dy is calculated at y equal to y0. Then equation of that flat surface at any point. This is xy plane. Now this is a sphere. If I talk about if I talk about in any point here, that is x0 comma y0 comma some z, that is function over x and y, then if I go and map, if I see from the top, and then if I map that point on the xy plane, that point will come as x0 y0. At x0 y0, what is the equation of the tangent surface? That is dz by dx into x plus dz by dy into y, where dz by dx is calculated at x equal to x0. dz by dy is calculated at y equal to y0, and then I get the equation of the surface. What is delta z? Then delta z equal to dz by delta z at that moment, where x0, y0 is there. If I move x little bit, means x0 plus delta x, and y I move little bit, that is y0 plus delta y. I have a new point x0 plus delta x, comma y0 plus delta y. If I move x delta x and if I move delta y, so that now x0 y0 was the previous point, a new point is x0 plus delta x, comma y0 plus delta y. If that is the case, then how much change in the at x0 y0 there is a z, x0 plus delta x comma y0 plus delta y, there is another z. If I make delta x and delta y change in the xy plane, how much change I see as delta z? That is under question mark. Then if z equal to dz by dxy, dz by dxx plus dz by dyy, then delta z equal to dz by dx delta x plus dz by dy delta y. Make sense? Okay, so at any point x0, y0, if I make delta x and delta y change, the delta z change, what we see, the delta z change, that is dz by dx delta x plus dz by dy delta y. Now, no need to calculate dz by dx at x equal to 0 and dz by dy at y equal to 0, because dz by dx can come as algebra. dz by dy can come as algebra. If it comes as algebra, then we have generic delta z formula. That is dz, if I say delta z tends to 0, dz equal to dz by dx plus dz by dy. Consider z is function over x and y, that is g. Then d of g equal to dg by dx into dx plus dg by dy into dy. Now the actual energy calculation was F1 dx plus F2 dy. If F1 is dg by dx and F2 is dg by dy, then dg by dx into dx plus dg by dy into dy is dg. So if it is path independent, when dg by dx equal to F1 and dg by dy equal to F2, then the net calculation of energy is F1 dx plus F2 dy will become dg. Integration of dg is g. Then you get the net energy calculation from A to B. Now G is dependent upon F1 and F2 only, because the net energy calculation is F1 dx plus F2 dy. If I replace F1 as dg by dx, then G is directly dependent upon F1. If I replace F2 with dg by dy, then G is directly dependent upon F2, not on the path. Dg by dx into dx plus dg by dy into dy will become dg. This is what we are seeing as per the calculus fundamentals. Dg integration is g. Now we have learned that g is only dependent upon f1 and f2. If the integration is g, then limit a to b. Now g that is coming as the net energy calculation is dependent only upon f1, f2 and lower limit and higher limit. This is our proof. This is not available in any of the book. Means how you prove that if you have energy calculation is f1 dx plus f2 dy and it comes as g, and g is dg by dx is f1 and dg by dy is f2 somehow, then if that is the case, then how you can say it is path independent? Certainly it is path independent, because dg by dx is f1, then g is dependent upon f1 only. Dg by dy is f2, then g is dependent only upon f2. Then this equation becomes dg by dx into dx plus dg by dy into dy. Indeed, it becomes dg only. Then integration is g and lower limit to higher limit. If you say, then g is only dependent upon f1, f2, that is force vector field. Force vector field f was f1i plus f2j, and then lower limit and higher limit. So this is the biggest invention that happened in arena of mathematics, that you prove through vector that a vector field is path independent. I believe it is too much time. We will talk more on it, and other proof. There is something called curling, and those proof that also we will see. It is too much time we took. So this is the proof not available anywhere else, that indeed if dg by dx is f1 and dg by dy is f2, then how it is path independent? There can be other arena also. Please do support us. +91 is the India country code, 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. We will see.